Teaching irreversible changes can be quite difficult because it's quite an abstract idea. To start with, you need to establish what the children already know about reversible and irreversible changes.
What could we do? Something with our hands, something with our bodies?
I like to encourage the children to put actions into science to help them remember the key aspects of the different vocabulary that we use. And in this idea, I asked them to come up with an action for an irreversible change and a reversible change.
Brilliant, well done.
So that when they see different changes, they can use their action to show what they think's happening.
Making bread. Everybody's agreed. Chocolate melting. Salt dissolving in water. Brilliant. I'm going to show you the equipment that I'm going to be using today. Okay.
These are the things that you're going to need. A milk bottle, some bicarbonate of soda, a balloon, and some vinegar.
I'm going to take the balloon, I'm going to carefully put the balloon onto the top of the milk bottle, and then I'm going to turn the balloon up so that the powder falls out into the liquid.
It's a good idea to get the children to predict what they think will happen. This will give you an instant insight into who's beginning to understand what an irreversible change is, who's looking closely at the equipment you're using and trying to draw upon their own knowledge to think what might happen next.
If you've said you think the balloon might inflate, can you say why? Try and add something to the end of your prediction now to make it better. Who'd like to share now their improved prediction?
It will make a bang because the powder is combining with another chemical. It will dissolve in the liquid and it might fizz. And I think this is because there will be an irreversible reaction.
Brilliant, well done. What I want you to do now is to observe closely what happens. Putting the balloon on the top.
Children always love this activity, so you can do it more than once and they still react in the same way.
Whoa! Is it going to pop?
So who thinks they can explain what happened?
Finn. The white powder reacted with the liquid, which let off a chemical reaction and a gas, which made the balloon inflate.
Fantastic explanation. So, if a new product is made, show me the action. Is it reversible or an irreversible change? Everybody's showing me an irreversible change. Well done, you're right.
This is alien soup, and in a mixture based around water, there's sand, rice, salt, and metal paper clips in there as well. Your challenge is to work out what exactly do these aliens eat, what's in their soup, and how much of each type of thing do they have.
Is one of you going to put stuff in here, like tip it?
Children really like this activity because it's a mystery. They're excited to find out what's in it. They're left with lots of different kinds of equipment: sieves, filter paper, beakers of different sizes, funnels, magnets, and it's for them to decide how they're going to use it to separate out those mixtures of materials. The children are working independently, but sometimes you do have to step in just in case they're not sure about how to use the apparatus in the right sort of way, or to just challenge their ideas a bit. So how are you going to get the sand through these holes now? Because they're quite big holes. The rice won't go through though. How are you going to get that sand through?
We should pour the fresh water through, maybe.
Well done. Let's give that a go.
Yeah, cool.
And if you swirl it with your fingers as well and swish it around. That's it. Try and let that sand go through.
I want to see all the sand, like I can see stuff going through.
After the children have separated out all the parts of the alien soup, bring them back together and talk about how they did it, what piece of equipment they used for each stage, and then which order it was best to do it in. What did you separate out first? What was the first thing to go?
Paper clips with a magnet.
So we can take the paper clips out and we use the magnet for that. And you can do that by moving things around on a flow chart to get them in the right place in the right sequence of events. And what was the last thing to separate out?
We took out the sand.
The sand, well done. What did you use for that?
We used the beaker, filter paper and funnel.
Well done. When you separated out the paper clips, the rice and the sand, you're left with what you think is just water left. You can't see anything in it, but does that mean there's nothing else inside it? There's a bit of a twist in the tale when it comes to the end, because the children usually think that they've sorted it and they've separated every material out there. Is there anything else that could be inside?
Bacteria.
Well done. Anything else that still could be inside?
Maybe bits of sand inside
There
it.
probably are some small particles of dirt and sand in there. Well done. Think about when you pick up seawater. There's something else inside seawater that you can't see, but you know is there because you can taste it.
There's salt in seawater.
How would we find out if this contains salt? What could we do?
You'd simply drink it.
You could drink it down, but because Mia said about there being bacteria and maybe germs inside there, it would tell us if there's salt, but it might not be safe for us to drink.
Most of the rainwater comes from the sea, but it's not salty, so the salt doesn't evaporate, so we could try that.
So if we took some of this water and poured it onto our saucer and leave it for a couple of days on a sunny windowsill, leave the water to evaporate, and if there's salt crystals there, those salt crystals should be left behind. The great thing about doing hands-on activities is that children are finding things out, and we as teachers can work alongside them at the same time, because they're seeing then how we work too. It's all about that problem-solving mentality.
This is a really good activity because it uses something that children know about and that children have fun with. Who's ever built a snowman before? What do you put on your snowman when you've built it? Adam?
A carrot nose.
Coal for the buttons.
Lovely.
We'll put the hat and the scarf on.
Excellent. Has anyone ever put a coat on a snowman before?
No. I have.
I used the book The Snowman's Coat, which offers 3 different points of view. It's a winter's day and it has been snowing outside. Rusty, Joe and Alex are making a snowman. They want to stop him melting in the sun. And they've got 3 different ideas. This person says, don't put the coat on the snowman, he'll melt. This person said, I don't think it will make any difference. And this person says, I think it will keep him cold and stop him from melting. Have a little think time. What do you think?
I think it will melt because coat's supposed to keep you warm and it does, doesn't it? So it's same with the snowman and it'll melt.
It's useful for the children to have those ideas in front of them because they're able to agree or disagree with somebody else. So it gives them the confidence to say what they think.
And it's fun.
We are proper scientists, aren't we? And we have to think about how we're going to answer the question. Does anybody think they could tell me how they think they're going to answer this question? What are you going to need to do? The book presents a problem which the children need to investigate.
We get an ice cube, put it in a tray and then put material on top of it and see if it melts.
Oh, what a good idea. We could use ice cubes. What we're going to do is we're going to get 1 block of ice and we're going to put a sock on it. And that's going to be the snowman's coat. Then we're going to get another block of ice and we're just going to leave that without a coat. They go away into their groups and each group has 2 snowmen, 1 with a sock on it and 1 that stays uncovered. It's really important that the children don't handle the ice too much because the warmth of their hands will cause it to melt.
It's wet.
Using words and pictures, record in your first box what the snowmen looked like at the beginning. The children then record what they see at the beginning of the investigation. At first, the children won't see much of a change between the two snowmen, but after about half an hour, they're able to see that the one that's uncovered is melting more quickly than the one that's covered, and they'll be able to draw and make notes to explain what they can see. Because children put coats on themselves to keep themselves warm, their experience of putting a coat on something is to heat it up or to keep it warm. They have very little experience of keeping something cold. The wonderful thing is that they go from thinking that the one with the coat on will melt straight away to complete surprise when the opposite happens.
And this one's hardly melted. It's just that one melted really low.
This is a great lesson idea that gives children the confidence to take part in science, because it's not something that's big and scary and that they don't know about. It's something that is familiar to them.
This is a great idea to show floating and sinking. In fact, it's kind of a DIY lava lamp. First of all, you need to pour lemonade into a clear vase. Then you show the ingredients to be dropped in. What do you think will happen when I add the raisins to the lemonade? Ask the children to predict the results.
I think the raisins will float because the raisins are lighter than the lemonade.
I think it might do both, because when you drop it in, you've got the force of the drop, so it might sink and then it might float back up to the surface.
I'm going to add 6 raisins now. Drop the raisins into the lemonade. Observe what is happening. We get lots of ideas through density, expanding and absorbing, and the air going into the skin, all sorts of ideas.
When the raisin has lost more buoyancy, it goes down to the bottom.
You can experiment with all sorts of items, popcorn kernels. Grapes and satsumas work really well too.
What happens?
This activity is perfect for the children to actually look very closely, and then they can match their prediction with what they're actually seeing. In fact, they're actually behaving like scientists.